Okay. All right, so what we're doing today is we're continuing our discussion on organic chemistry. I'll give you some understanding. First and foremost, I thank you so much for all the work that you guys put in. If you guys put the work in, some people more than others, but I do thank you for the show that we put on Thursday. A lot of positive feedback, and a lot of kids were in awe of you, okay, and the things that we did. So I do bottom of my heart, and that's a big heart. It'd be I guess it'd be the ventricles, the bottom of my ventricles. I do thank you for that, for the time putting in, and I still haven't cleaned up yet. And the idea, what we're doing to the end of the year is, and again, I'm recording this for those that could make it, and I'm showing up early today because there's a parade for the high schoolers, and I want to be sure I'm there for the seniors. And if you have a brother or sister that's involved, I get it too, but this is recorded. Any case, that being said, thank you for Thursday. It went really well. Very difficult on my end because I couldn't see people's reactions. It was very weird to be presenting in a room in a school by ourselves. But in any case, my boys had fun, we had fun, and in fact, I actually had a blast, imagine that, or two. In any case, what we're doing is we're gonna complete the course by me finishing out 2 units that weren't covered or not part of the AP curriculum. The reason I'm doing that is because maybe you wanna take the Regents in January. You don't have to, taking the AP is good enough, but I wanna make sure that there's no gaps in your learning. And so I'm gonna finish the course by finishing out these 2 Regents chemistry units, and we'll have plenty of time to do that, and they shouldn't be that difficult. Sorry for the forms, I brought them back, but I don't know how else to teach you in this kind of format other than that, and I hopefully you can see I'm not trying to beat you up on that. That's why I gave you 3 opportunities. So let's pick up where we left off. I want to talk more a little bit about the naming system. We're going to go into it a little more hot and heavier today. Okay, not that much. It's Regents level, and we'll do that. So I'm going to share my screen. Okay, and we're going to go on to 1,000 forms, 1,000 tabs open, and we're going to go to my website, our website. I don't know if it's mine, yours, who knows. Okay, probably Google's. Any case, what we're going to see here is the IUPAC naming system is the International Union of Pure and Applied Chemistry. It's basically an association that's been together since 1913 to help with chemistry. Remember, chemistry didn't take off until the 1850s, right? We talked about that ad nauseum. But here it was a group that came together to help name elements and all kinds of unstandardized some things. And of course, the naming system, and it's an international authority, so everyone is talking about the same chemicals. And remember, the important thing here is the naming system is based upon structure. Okay, so I'm going to pick up where I left off yesterday, and hopefully it was clear enough. And sorry for the bringing back the forms, but hey, that's the way it goes. Okay, so I think we were at slide, I don't know, was that 32? I don't know. Yeah, something like that. And there's Rob there. Rob actually is as a medical doctor now. Yeah, there's Mr. Gradski again. So here we go, picking up our naming system. And now we have these cyclocompounds. Okay, so we have the parent name, or the parent chain that we learned yesterday, which is nothing more than the longest continuous chain of carbons. All right. And we identify if they are a single or double or triple between them. And then we're going to put something in front if there is something attaching. But in this case, what we have is a cyclic compound. Cyclic compounds are when like the head bonds with the tail. And we just put cyclo in front. Notice there's 1, 2, 3 carbons. So therefore it's a cyclo, but it's a prop. Prop for the 3 carbons. Table P is your friend. And if you don't have your table P and Q out today, I will post them. Okay, but 3 carbons is prop, meth, eth, prop, right? And then single bonds is propane, and because it's a cyclic compound, they put cyclopropane. Now, in biochemistry or in biology or organic chemistry, they love to draw just the carbon backbone. The corners are the carbons. And because there's just one line here, it's a single bond. So this is cyclopropane. Let's go on. So if I drew you a rectangle, okay, this is cyclobutane. Now cyclobutane, of course, is this. Notice there's single bonds between the carbons, and each carbon would have to have CH. It's important that the cyclo compounds would not follow okay, the general formula in table Q because of the idea that we have to lose two H's, right? If these were a long chain, this would be a CH3 ending. So it would not, we wouldn't call these unsaturated or saturated, just it's a different type of structure, all right? This is a pentagon, right? And it's got 5 corners, 5 Ks. They eliminate the H's here in the structures. This should show the carbon backbone. And of course, it's a pentane, single bonds, and a cyclopentane. Okay, so what would we name this structure? Now, of course, it's hard to see, but these are single lines. So what would be the name of this? How many carbons or how many corners do you see? Somebody jump out there and help me out. Well, it's a cyclic compound. Yeah, cyclohex. Cyclo, because the tail is bonding with the head. Hex, because there's 6 corners or 6 carbons. And because you don't see a double or triple bond here, it's an ane. So cyclohexane. And by the way, cyclohexane is what I used in the second whoosh bottle. It's also the chemical I used in the flaming book, okay? It basically is lighter fluid, haha. Okay, so now we're gonna get a little more complicated. We're gonna add something called substituents to the parent chain. The parent chain is the longest continuous number of carbons, and then there's gonna be things attached to this parent chain. So let's start with this. We have the longest continuous chain of carbons, 1, 2, 3, 4. That is, if you go to table P, a bute, okay, or a but, okay? Now, there's single bonds between the carbons, so it's a butane. But then we're gonna have something attaching. So we're gonna just, for fun, put a Gradski there. So I'm putting a Gradski there. And there's a Gradski, all right? And so we need to say that we have a Gradski attached to this parent chain. So what do we have? Well, we have a Gradski on the second carbon, okay, attached to a butane. So we would say 2-Gradski butane. Remember, the IUPAC nomenclature is about the structure. Structure is king, okay? Now you may say, Mr. Gradski, what if I count 1, 2, 3? Well, that'd be wrong, because in the IUPAC naming system, this bunch of chemists came together in a big party. Sounds like a lot of fun. And they said, well, we think that we should name them on the second carbon, okay? The lowest number possible, okay? So they did, and I don't know if they talked that way. They probably didn't. So this could be 3 or 2. They decided by a convention that it will be on the lowest carbon possible. So when you number your carbons, and you're gonna number the longest continuous chain of carbons, okay? Continuous chain, we're gonna see it's not always gonna be continuous. So what's not continuous is attaching group. So I've got Gradski outside of this longest continuous chain, and I'm on the lowest number carbon second. So 2-Gradski butane, okay? Now let's do it again another way. So let's put Gradski on this parent chain, longest continuous chain, and let's put another Gradski here. All right, so let's name this. All right, so what's the longest continuous chain that we have? I'm pausing for someone to answer. Longest continuous chain of carbons.
6.
Right, 6. And therefore, based on table P, a 6 would be a what? Well, it goes meth, eth,
Hex.
hex, yeah. Like I'm putting a hex on you by watching this. So no, I'm not, but it's a hex. And because there's single bonds between the carbon, it's a hexane. But Gradski's not part of this longest continuous chain. So what's on the hexane? A Gradski on the 1, 2, 3, 4th carbon, or a Gradski on the 3rd carbon? By the IUPAC naming system, should I have it on the 3rd or the 4th?
The 3rd.
The 3rd, yes. So we would say 3 Gradski hexane. Now, of course, there's no Gradskis attached to hexanes, but you get the idea. We put a Gradski. So look at this. What if I was able, again, we're going to do this for work of home. What if I had you guys draw this? You would say hex, okay. Ooh, yeah, you should. Remember, don't lose the subliminals here. Even if you miss them, your brain has them. At the end of this, I don't know, presentation today, I'll make a sound. You guys will cluck like a chicken. No, I can't hypnotize you like that. But in any case, so we have a 6, Christmas. We have a 6 carbon chain, single bonded between the carbons. And on the 3rd carbon, there's a Gradski. The name describes the shape. Structure is king. Okay. So party people, we're not going to have Gradskis. We actually don't have Gradskis, so we're going to have something. Now we're going to have single, double, or triple carbon groups. Now notice, if we have a one carbon group attached to the parent chain, okay, we call it a meth, and we add a YL. I should have an L there, okay? So a methyl group. If it's a two carbon group, it's an ethyl group. Notice the H's. The H's really tell you something. If this carbon is bonded to another carbon, because carbon makes 4 bonds, okay, it has room for 3 H's. Notice this carbon in a ethyl group, a 2 carbon group, if it's bonded to the parent chain carbon, and this carbon is bonded to this carbon, I know it's a little confusing, but if you draw it out, you'll see that this is bonded to this carbon. This only has room for 2 H's, and this terminal carbon has room for 3. So it makes sense. All right, so the first step, and this is the same structure, is that we can number the carbons this way. Now, if I number the carbons this way, the longest continuous chain is a hex. And notice this group is not part of it. And how many carbons is that? 1. So this would be a methyl group. And you say, Mr. Gradski, why don't I just call this a 7 carbon chain and call this heptane? No, the naming system is about the continuous chain. And so you notice there's 1, 2, 3, 4, 5, 6, or look at me, look, watch, 1, 2, 3, 4, 5, 6, and that would be the out group. There's one carbon group that's not part of the longest continuous chain. That's the Gradski here. But notice there would be a 1 carbon group on the 5th carbon called a methyl on the 5. Would this be a good way? Is this correct? And the answer is no, rock off, no way. Because couldn't I number it in a way that this would be the 2nd carbon? Yes, we must number the attaching groups. So I number it this way, so that this out group, this 1 carbon group that's acting like the Gradski, that's not part of the longest continuous chain, okay, is on the 2nd carbon. It's convention. They came together, they had a big chemistry party, okay, probably with apple juice, all right, and they decided we're going to decide that make this the longest. So what do we have? The name. Longest continuous chain is a hex. This is a hexane, and it's important you realize why. These carbons are bonded together. This ending carbon has 3 H's. This middle carbon has to have 2 because this carbon's bonded to this carbon and this carbon. 4 bonds every carbon must have. So the CH2, notice this is only CH because this carbon's bonded to this carbon's bonded to this carbon, and this carbon's bonded to this carbon, call it a tertiary carbon. So it only got room for 1 H, so it makes sense they're single bonds, or draw it out. So what's the name? 2-methyl hexane. Remember we said 2 Gradski something? On the 2nd carbon, we have this methyl 1 carbon group attached to the hexane, longest continuous chain. If you name this 5-methyl hexane, that'd be wrong. Remember, the naming describes hex, 6 carbons, single bonded. And we've got a 1 carbon group bonded on the 2nd carbon, and we throw in all the H's so that every carbon has 4 bonds. Okay, now you could have drawn this on this side, and we'll talk about that in the homework. Okay, so here's another example. The first thing is to try to find the longest continuous chain. What a lot of introductory organic chem students will do is say, oh, going across, I'll count 1, 2, 3, 4, 5. And this is a 2 carbon group. Wrong, wrong. Longest continuous chain. I showed you yesterday Rob, okay, who's another medical student I keep talking about, all right? And he was actually in the first AP Chems class I taught here. All right, any case, these things, if they're single bonded, they can rotate. So the idea that they go straight across really isn't true. They actually are tetrahedrals on each other. So another better way is up, down, but these things can turn themselves. So what's the longest continuous chain? Don't fall in love with it's gonna be, don't be a robot and count straight across. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I don't know, I think I snored right there. Okay, all right, so any case, I count this way. And this is the 1st, 2nd, 3rd. That means that, hey, that's not part of the longest continuous chain. That's a 1 carbon group. And there's my methyl group. Okay, so what's the name? Well, longest continuous chain, 6. These things are single bonded. Okay, I can tell by the what? The hints, the H's tell me, right? CH3 is terminal. This middle carbon has to have 2 for same reasonings. Okay, this one should be CH2 if this wasn't here, but because it's bonding to an extra carbon in the middle, it only has room for one more H. So on the third carbon, I have a methyl group. And then, of course, I have the hexane, 3-methylhexane. Now, whether you break the word apart or not, it's fine. Hey, your homework tonight, okay, or this month, depending upon when you take a shower, okay, this year, is look at your shampoo bottle, and you're going to see at the bottom, you're going to see they use a lot of industry names like color number 3 or fragrance number 5, but they also list chemicals, and the chemicals will have names and groups, more advanced than us, but you'll see some things with long names that go around the bottle. As these structures get bigger, the naming has to get bigger because it's based on the structure. So your shampoo is made of organic chemicals and they're named, and you'll see numbers and dashes the same way. All right. All right. So let's go name this chemical formula. Don't fall in love with the longest continuous chain is a straight line. Find the longest continuous chain. Okay. And I'll give you a second to think about that. Let you think about the name too. All right. So this is me numbering 1, 2, 3, 4, 5, 6. Notice who doesn't fit the longest continuous chain right here. Now, could someone have named this the first carbon and this the second carbon and this would be the methyl group? Absolutely. It doesn't change a thing. Okay, remember these things rotate if they're single bonds. And if you look at the H's, they are single bonds. This should look a lot like what we just did, doesn't it? Right? They can be conformationally rotatedly a little bit different, but they're still going to have the same properties. So I have on the second carbon a methyl group on a 6-carbon longest continuous parent name that's single bonded between the carbons. So 2-methylhexane. It's the same one we just drew. I just showed you a different way. These things can rotate. All right. So 2-methylhexane. All right. Very good. What's the name of this compound? Someone try this one and just yell it out if you have it. How many corners do you have? Is it bonded to itself? Who's got this name? Yell it out loud and proud. Now, this is a 2-carbon group. Go to table P. What's 2 carbons? F. And if it's an attaching group, it's an ethyl attached to a cyclic compound with 6 carbons, single bonded to each. So what would be the name of this? Anyone's mic on? Ethyl. Oops, that's probably true. Ethyl.
Cyclohexane.
All right, thank you. Great. All right, ethyl cycle. There's an ethyl group, 2-carbon group. Notice why the CH2 is here. This carbon's bonded to this corner, which is a carbon. It's bonded to this carbon, only has room for 2 H's. Hey, terminal carbon that's single bonded must be CH3. They don't show the H's here. Ethyl group to a cyclohexane. All right, moving on. Okay, that's weird. Not sure how that got there. All right. So now we go on to multiple substituents. Okay, now we're going to have multiple. So it's going to bring back the Gradski. All right, so here we go. First thing when you name, we're going to add some Gradskis here. So let's put 2 Gradskis. All right, even though they look different, they're the same. This is when I did have some hair. This is many years ago I put this together. All right, so longest continuous chain, 1, 2, 3, 4, 5, and 6. So it's a hex. They're single bonds. Notice the CH2 in the middle. Okay, CH3 at the end. Okay, so hexane. But now I've got a Gradski on the 1, 2, 3, 4, 1 and 4, or the 1, 2, 3, 6. Is 3, 6 good or 1, 4 better based upon the convention of the IUPAC naming system? What do you think? 1, 4.
1, 4.
1, 4 is what you have to pick. If you say 3, 6, it'll be wrong. So 1, 4. Now we have 2 Gradskis. So what we do is, especially if you hate organic chemistry or me in general, you would say di, okay, for like a dicycle. Not that you don't want me around anymore. So you would say Gradski. Now, it's important that every attaching group gets its own name. So if you say Gradski hexane, you wouldn't be telling me where the Gradskis are. So I need a number for every attaching group. So this is going to be 1,4 di, because there's 2 of me, or 2 methyls, not because you don't like me. And we're going to name, and of course it's a hexane. So 1,4 di-Gradski hexane. Now, if there were 3 Gradskis, we'd have 3 separate numbers, and we would use the word tri-Gradski. And if there were 4 Gradskis, we'd have 4 numbers, and we would have tetra-Gradski. Okay, so di, tri, tetra. Remember, every attaching group needs a number. Think, while you're trying to figure out the name, think about how I would draw this. If you said 1 di-Gradski hexane, I wouldn't know where to put the second Gradski. All right, so let's continue. So let's do this name. First thing is find the longest continuous chain. 1, 2, 3, 4. 1, 2, 3, 4. No matter what I do here, the longest continuous chain is going to be a Gradski. Okay. And so I'm going to make this 1, 2, 3, and 4. I just counted my carbons. So my longest continuous chain is right here. That means, party people, that this is an attaching group, CH3, and this is an attaching group. So someone give me a name.
Would it be 2,3-dimethyl propane?
Close. You
Or
got
no, butane.
That's it. Perfect. Absolutely. Okay, absolutely. 2,3-dimethyl butane. On the second carbon, you've got a methyl group. On the third carbon, you got 2 Gradskis. So if you would di, so instead of Gradskis, these are methyl groups. They're not part of it. Bute for the longest continuous chain of carbons. Ane because there's single bonds between them. Perfect. All right. So that's how it goes. Okay, and we're moving on. All right. Someone else named this one. Very similar, but a different structure, therefore a different name. All right, so if I wanted to draw, and I'll make this, now I could count, is this going to be, the longest continued chain is 4. Would this be the third carbon or the second carbon?
Second.
Yeah, 1, maybe. Christmas in July just gave that away. All right, so that didn't work out too well. So these are both the second carbon. So notice this is 2,2-dimethyl butane, still a butane, longest continuous chain. These 2 groups are methyl groups, but now this is 2,2-dimethyl. The previous one was 2,3-dimethyl, different structure, different name, different properties. By the way, 2,3-dimethyl butane and 2,2-dimethyl butane are isomers. They have exactly the same number of carbons and hydrogens, same formula. They would use the what? They would use the same general formula. Okay, remember that general formula we learned last night? Okay, or yesterday? Okay, which is CnH2n plus 2. So we have what? C6H what? (14). They're both the same molecular formula, but different structures, different properties. Thank you for playing. Okay, moving on. How would we name maybe this one? All right. So this one I kind of color coded for your viewing pleasures. Longest continuous chain is 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Don't fall in love with going across. However, we can use going across in this case. Okay. So the first step is always to find your longest continuous chain. Okay. Now the question is, if I number across 1, 2, 3, 4, 5, this would be a 3, 5 or 2, 4. So I'm going to number this 1, 2, 3, 4, 5, and 6. This reminds me that I'm going to count this way, and I have a 1 carbon group here, and I have a 2 carbon group here. Based on table P, this is called a what? A meth. We add a YL for a methyl group. This is a Gradski. This is a 2 carbon group called a what? Ethyl, correct. Now, how do we name this sucker? Well, we start with 1, 2, 3, 4, 5, 6. This is single bonds based upon what the H's are telling me. So, of course, this is a hex. It's an ane. But now what's connected? Well, party people, we've got an ethyl group. Now, I'm going to put E before M. So I'm going to say for ethyl, every attaching group must have a number. 2 methyl hexane. And that's it. And you say, well, why did I
Shouldn't
put...
it be di?
No, because...
Oh, because
yeah, if these were the same attaching group, you'd be right. But because these are 2 different, they don't need a di or tri. Okay? And so that was a good try. So, and I think I have this backwards. Okay? So I have 4 ethyl, 2 methyl. I think I have it right. Okay, 4 ethyl, 2 methyl. And the idea is that the E goes before the M because of, someone's like, E goes before M based upon alphabetical order. If you put 2 methyl, 4 ethyl hexane, I'd accept it. No worries about that. Okay, now if you go to table R, okay, in your reference table, okay, you'll see that the halogens can be the Gradski, can be the attaching group as well as the carbons. They have some funny names: chloro for and bromo, fluoro for F, and iodo for I, if you're into Star Wars. Yoda, iodo. Okay, sorry. The point is the halogens can be that, so we have to use these prefixes given to you in table R. Okay, so here we go with this guy. Longest continuous chain, 1, 2, 3, 4. That's a bute. Single bonds, butane. Hey, I've got 2 chlorine. So how do I name this one, you think? Well, I've got chloros. And they're both on the 3rd carbon or the 2nd carbon?
The 2nd.
Right. So would this be correct? 2 dichlorobutane. Would that be correct?
No.
No, because yeah, go ahead, Cole.
2,2-dichlorobutane.
Perfect. Yeah, you need a number for every attaching group. The di is because there's 2 of the same chloro. 2, the butane is 4 carbons, ane for single bonds. That's pretty straightforward. Okay. All right. How about this one? Please try this one. Sorry. Okay. Someone's doing like Morse code. I don't know what it means, like, Gradski, you're boring in Morse code. Stop it.
Would it be 1,3,3 trichlorobutane?
Oh, you should. Okay, you're showing off. Yes, 1,3,3. Some people say 2,2,4. So 1,3,3 trichlorobutane.
I got 2 weeks.
All right. Wherever you're talking to, make sure you mute your own speaker there. All right. So 1,3,3 trichlorobutane, showing off. Obviously, some people could have said this is 2,2,4, and that'd be wrong. Lowest number possible. Okay. And then this one. Oh, we got a butane again, but we've got 3 chlorines.
1,1,1 trichlorobutane.
Yeah, it's that simple. That's simple. Okay. And some people like this at some point. Some people never do. But that's it. Okay. All right. Name this compound. Is it 2,5,5 or 1,1,4?
1,1,4 dichlorobromopentane.
Okay. You got pieces of that right. You got to stay with the same thing. So let's keep the, let's go do the bromo first because B goes before chloro, right? So keep the bromo. So we're going to make this 1,1,4. So we got to say 4 bromo, 1,1-dichloro, and then it's 1, 2, 3, 4, 5 pentane, right? So I should have put bromo first before the dichloro, but hey, it doesn't matter. So 1,1-dichloro, 4 bromo, pentane. You get the idea. They keep it together. You kind of jumped around there. All right. Moving on. Alkenes. Guess what? These guys are unsaturated. We did this last night. This is ethene based on table Q for quinine. And there they are in all their glory. These guys are unsaturated. They have under the amount. We talked about that. So here we go. Which of the following is an unsaturated hydrocarbon? Which one is not an alkane? Well, alkanes have the max amount of H's, and the general formula is you double the carbons and add 2. All right, so which one is unsaturated? Which one's either an alkene or an alkyne? Which one do you think? Let's see what the great Gradski thinks. And here he comes. There he is in all of its glory. All right, it's not a toupee. One time I did have hair. Okay, now C3H6 party people is double the amount of what? H's compared to N. So it has a double bond there, okay? So pretty simple stuff. Now, naming this compound. Last night I made you name these, but I kind of left something out because you weren't ready. Now you're ready. Where is that double bond? Well, first of all, 1, 2, 3, 4, 5. That's a pent, okay? Now, second thing is, now we know there's a double bond here. This should have an H, CH2. This should be CH3. We took off 2 H's. That's why it's what? CnH2n, not CnH2n plus 2. We lost 2 H's because we're not holding the max amounts. It's unsaturated. So this is a pentene. But just like attaching groups, we have to describe where the double bond is because the shape's going to change, right? 1, 2, 3. This is going to be trigonal planar, even though we're not driven. This is trigonal planar. This is tetrahedral. So the structure is going to change depending upon where the double bond is. So we're going to always number where the double bond starts. So this is going to be pentene. It should be numbered 1 pentene. Okay, yes. And I don't have it there, but I should have 1 pentene. I feel bad now. I'm over it. Okay, so when it's not the first carbon, we do this. So where this would be 1, 2, 3, 4, longest continuous chain. So it's a bute, and I gave it away. On the second carbon, the ene starts, and there you go, 2-butene. So when you name, okay, ines and enes, double and triple bonded compounds, you've got to put a number, not for the attaching group, well, you will eventually, but you have to put a number for where the double bond is. And notice we put it on the shortest. So if you notice 1, 2, in this case doesn't matter, but it goes in the shortest number also. And by the way, if I was to put a methyl group somewhere, what dominates the numbers where the double bond is. So if I was to put a methyl group here, that methyl group could not be 1. It would have to be 4 because this is this, well, actually it could be 1 because that's the second carbon. That's a bad example. But what dominates the numbers is where the double bond is, okay? All right, so this is a weird one because this is a polyunsaturated compound. So watch how I name this one, okay? 1, 3, it starts in the 1, starts in the 3. I wouldn't say 2, 4, right? Always a lowest number combination. Now it's bute, I'm sorry, 1, 2, 3, 4, 5, pent. Now it's a pentene. So you may say 1, 3 pentene, but they add an A to say, so they put a di in there. Notice the di is part of the ending name. So watch what they do. So 1, 3 pentadiene. And the reason they put an A there is to make it sound nice. 1, 3, and the diene is there's 2 enes. Notice the di is at the parent name because this is still part of the parent name. It's not part of Regents chemistry, but it's fun to look at. So pentadiene, pent for the 5 carbons, di for the 2 double bonded structures, and you put that in front of the enes. There's 2 enes, numbers for where they are, and the A to make it sound nice. Okay, hey, rock on. I love it. Okay, so what's the name of this compound? Notice it's a cyclic compound, and notice something right here. So this would be ethyl. This should be bonded here in this corner. Cyclo. How many corners do you see? Hexene. Right? The other one we did was cyclohexane. Take the double bond off. All right. So there it is. Good times. Yep. Oh, not sure how that got there. All right. Alkynes. These guys have less. Their general formula is -2. This is F and an ine. Okay. They're even more unsaturated because they have even less H's. Now notice, what's the name of this compound? I took this picture myself on the North Shore. Everyone loves the South Shore. I love the North Shore. That's where I live, North Riverbed. Okay, so how do we name this? This is confusing. CH3, okay, CH2. Whoa! This should be CH2, CH2, CH2 if it was a what? An alkane. How did I lose 2 H's? Well, if this is bonded to this carbon, and this is bonded to this carbon, I should have 2 H's, so it must mean I have a triple bond between these C's. If these 2 C's are triple bonded, they only have room to bond to the carbon on one side and to the other side. That's why it's unsaturated. So that triple bond is where? On the 1, 2, 3, 4th, or starts on the 3rd? Starts on the 3rd. Longest continuous chain, 1, 2, 3, 4, 5, 6, 7. That's a hept, and it starts on the 3rd carbon, 3 heptyne. Okay, so there's my saturated, the single bonds holding the maximum. Here are my unsaturated, even more unsaturated, the alkynes. All right, forget about the benzenes. Okay, not part of the course anymore, and we'll get to the functional groups. Another shot from North Riverhead. That's all, folks. Directed by me, watched by you. You guys stink, PU. Yeah, okay, great. Okay, so that is our lecture for today. Hope you found that interesting or not smelly. Okay, and what we're going to do for this evening, or if your homework, is you're going to do the alkene naming worksheet. I'm going to post a key. I'm also going to post a video how to do that. If you downloaded it before the lecture started, I did have some mistakes, so I did fix them. So download this, or just put your screen on and name them and draw them on a piece of paper. I will have a key up before I leave today, and I will post and finish my video if you want to watch me do them. That's for tonight. Tomorrow we don't meet, and Thursday we don't meet, okay? But I will have up an assignment or to do, and we will meet back here Friday at 9:30, okay? All right, I've got to run to the parade, okay? And hopefully I blend into the crowd, which I know I won't. All right, and in any case, I want to stop my share, see if anyone's here. 18 for those that couldn't be here. It is recorded, and I'll post it for those that didn't see it. All right, any case, have a great day. If there's any questions, email me. Okay, I've got to run today. Good luck. Hope that helped. See you guys.